Welcome to our next lesson, an installment in section 11.6 on quadratic functions and their graphs. We're not going to look at all of these ideas immediately following offering these definitions, but I felt it was important from early on in the process to at least have these in your notes, so when these topics come up, that you'll have a reference point of what exactly these are. So first off, we start with the definition of parabola, which I described, and we graphed three of them in the previous video. But a parabola is simply just the graph of a quadratic function, which will have a similar shape to the graphs in the first video. Well, by this, I mean it'll have generally one of two shapes. So here we have our x-axis and we have our y-axis here, and everything kind of graphed on the line here. But that's not always going to be the case. You're usually going to have some type of parabola that's going to be a curved line, and this is the type of parabola that opens upward. And one thing I'll kind of note here is that a parabola like this is going to have some positive x squared term with a positive coefficient in front of the x squared term. Another type of parabola, which is going to be similar in shape, but just slightly different in characteristic for the x and y graph, is some type of parabola that may open downward. And what we'll find here, generally speaking, is they'll see that the shape is essentially the same. Sometimes they can be narrower, sometimes they can be wider, but in this type of a parabola, we'll notice that the x squared term is going to be some negative. And now there'll be other things that follow, like it'll be x squared plus 3x minus 2, or some variation of that, or it's going to be written in a different form for the particular section 11.6. But what we'll see here is that the graphs are going to look generally like this. So this is what a parabola is. So let's take a look at vertex. And it says a vertex is the point on the top or the bottom of the graph. And we should be specific that it's a point at the top or the bottom of a graph for a parabola. So if you have a parabola that's graphed something like this, let's take a look at these two up here. We take a look at the point here, and we're going to go ahead and label this point as HK. And H and K are going to have a certain value. We use these letters specifically, and we'll talk about that a little later. That whatever the coordinate of this is, like this is x and this is y, that coordinate will represent the value of the vertex. So the vertex in this case is a point at the bottom of the graph of the parabola. Over here, we'll have the point at the top of the graph of the parabola. Again, we would label this H and K, and this will represent the vertex for the graph of this parabola. So when we talk about a vertex, all we're really talking about is the point that's going to be at the top or the bottom of the graph of the parabola, and whether it's at the top or the bottom will depend on which direction the parabola is going. The direction the parabola is going to depend on whether the value next to the x squared term, or the variable squared term, is going to be positive, which means it opens up like a smile, so a positive smile, or whether the number, the coefficient in front of the x squared term, is going to be negative, which means it's going to open downward or look like a frown. So negative frown. Just kind of a quick way to remember all this. So these 2 points now represent the vertex for each of the graph of those functions. Another thing that we're going to discuss a little later is going to be the axis of symmetry. So what we have here is a vertical line, and by vertical line we mean a line that's going to go up and down, that passes through the vertex. So when we have the graph of a parabola, and we'll go ahead and we'll put a generic parabola, we'll kind of just miss the graph here. Okay, we identify what the vertex of the graph is, and it's going to be a vertical line that passes through the vertex. So this will represent the axis of symmetry. Now, the reason we have an axis of symmetry is because one characteristic of parabolas is that all parabolas are going to be symmetrical across this line. Like if you have a point here that's 2 units away from this line, the point on the opposite side is going to be 2 units away also. It's not like this one's going to be close and this one's going to be far. That's not characteristic of the graph of a parabola or characteristic of the graph of a quadratic equation or a quadratic function. So we have here graphs of parabolas. They can go up and they can go down. Going up, they're going to be represented by positive x squared. Going down, they're going to be represented by some negative x squared. We have the vertex on each of these, which is going to be represented by a point either at the bottom or at the top of the graph of the parabola for the quadratic function. And then, to get the axis of symmetry, we're going to draw a line through the vertex so that we can see the symmetrical nature of the graph of the quadratic equation. So, this opens us up next to the last three things here, which we'll talk about. A maximum value versus a minimum value. So, a maximum value is for the graph of a parabola. For one that opens downward, this is the highest point. So, if we're looking at the maximum value of the graph, basically what you're going to be asked is when you're looking at a parabola, I'm going to move this up just a little bit here so you can kind of see this. A graph will either have a maximum value, or the graph of a parabola will either have a maximum value or it will have a minimum value. So in the case of the parabola here we have on the right, because this is going up, 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 we see that this graph has a maximum value at the point of the vertex. So if we're looking for the example of a maximum value, this example here will serve that purpose quite well. On contrast, we also ask about if the graph of a parabola or a quadratic function will have a maximum or minimum value. A minimum value is in the graph of a parabola that opens upward. This is the lowest point. So if we want to take a look at a minimum value, this graph here will serve well because we also see that the vertex is going to be, is at the bottom. One thing about maximum and minimum values too, the maximum and minimum value is also going to correspond to the vertex. So we see that the vertex has a lot of connections here. The vertex is connected by the to the axis of symmetry because the axis of symmetry goes through it. The vertex is also going to help define the maximum and the minimum value. And then the one last characteristic we talk about is range. So possible values for the function of y. For example, if we were to, let's say, look at this function here, and let's just say this is going to be 0, 3. Let's just say this point is 0, 3, and let's say that the x-axis is down here. So this is 3 above the x-axis. So if I were to look at this, I wanted to find what the range of this is. This graph goes as low as 3, but this graph on either side is going to increase to positive and is going to go up all the way to infinity. So for this first function, we would say up here, for this one, we would say that the range is going to go from negative infinity all the way to 3. And because it reaches 3, we go ahead and put a bracket there for the parenthesis. On the other hand, let's just go ahead and say that we'll go ahead and put an x-axis down here, and we'll call this point 0, 7. So we're going to go ahead and pretend that this axis of symmetry just kind of functions as the y-axis, and we're going to treat this point as 0, 7. So when we graph the parabola, making sure to put points at the end of my line, this function comes... Oh, I'm going to correct this one in a second, guys. I caught my mistake, and I apologize. This graph is going to come from negative infinity, and we have these arrows pointing down. This goes all the way down to negative infinity and comes up to 7. So for the range of this one, this is going to go from negative infinity all the way up to 7. I'm going to bracket that off. This one, on the other hand, goes from 3 up to infinity. So I'm going to go ahead and I'm going to correct that, and that's going to go from 3 all the way to infinity. So this is similar to the work we did when we were writing the solution to inequalities and compound inequalities. And you may recognize this notation here as being written in interval notation. So when we write the range of a function, you'll often be asked to write the range of the function in interval notation. So these are all the pieces that fit together. You will be asked questions about this in the next set of videos, and we'll be sure to characterize exactly what's being sought for in each of these questions. And please bring your questions to class as you desire more clarification on this.